Swayam Prabha. Digital India. Educated India.
And welcome to day 3 of the Gian course, Disability Interactions and Innovations. Today I will talk about some of the things that we do here at IIT Madras at R2D2, which is the TTK Center for Rehabilitation Research and Device Development. And specifically, I think in the context of what Professor Kathy has talked about in the last 2 days, we will look at the design journey for the standing wheelchair that we developed here. We will talk about, the challenges from going to the lab to the market, because one of the things that we have talked about, especially in the field of assistive technologies, is that there may be lots of innovations happening, but very few make it to the market, and there are challenges involved in that. So we will talk about the design journey, and that should give you an idea of what it takes to actually go from even a working lab prototype to a commercialized product. So that is the goal of this lecture this morning. So I'm a mechanical engineer, and most of the work that we do is in the area of movement disability. So where there is loss of functionality due to either impairments, aging, social conditions or environmental conditions, how do we design devices, how do we design programs that will help somebody to overcome these difficulties. We've seen in the last 2 classes that disability is not just about impairments. Sometimes it is just about the lack of the appropriate device and the training that goes with it, right? If I don't have my glasses, I'm disabled. If I put my glasses on, I'm no longer disabled, right? So I don't think of myself as disabled anymore because I can function the way I want to. So that is the idea behind the devices for movement disability as well. So the background is, what kind of motivates us is that just for locomotor impairments, there are over 30 million people in India. And in India, the situations we encounter, the kind of terrain we encounter, most places are not very accessible. You have steps everywhere to prevent insects from coming into a room, for instance. Like many of our rooms, right, or in bathrooms, because we use water, right? It's a social thing. We use water a lot in our bathrooms. We don't have bathtubs or, we don't use toilet paper. So what happens is our bathroom floors are usually wet, and to prevent that water coming out, you have like a small step at the entrance of the bathroom. But if you are a wheelchair user or a prosthesis user, that's something that you have to navigate. So it's a condition that's imposed by the architecture and the social behavior of our country. So there are challenges like this, in when you are trying to restore movement. So I just say movement in general. So it doesn't always have to be walking. Walking is one way of moving from one place to another. But a wheelchair is also perfectly fine as a mobility device. We use cycles as human beings, we use cycles, we use two-wheelers, we use cars. Those are also devices to enable movement. A wheelchair is just like that, so there are, so we need to start thinking about assistive technologies also in a different way, not look at look at them as something that is to be pitied or that is to be used only by someone, who is to be pitied, or that stigma attached to the use of assistive devices sort of has to start going, because I think with glasses we've now come to the point where it's even a style statement, right? My daughter, sometimes she has like 3 different glasses, no power, she doesn't need glasses, but if she's in the mood, she's feeling a certain way, it goes, she wears glasses, she says I'm feeling nerdy today, or I want to look a certain way, right? So how do we get other devices also to be looked at just as something that improves your functionality? Like Kathy said yesterday about the mobile phone, we've transferred so many of the things that our memory used to do to the mobile phone. We don't remember numbers, we don't, I have a calendar, I jot everything down there. With mobility, we are just transferring the ability of our legs to walk to another device. Okay, so we mainly deal, as mechanical engineers. Now we also have some mechatronics and electronics engineers in our group, but mostly so far we've been dealing with solving problems with mechanical engineering. And movement disability is what we have been trying to address. And some of the challenges in this space, and Kathy's also addressed that earlier, because it's universal. It's not restricted to India, it's not restricted to Africa, it's not restricted to, it is there everywhere. The challenges are affordability. Affordability is a huge challenge. Access. In many times, if you want customized devices, you need to have somewhere. Where do you get it from? Where do you get it from? Even the awareness about it is lacking, not just among users, but among the people like clinical professionals who should be prescribing these to the users, who should be telling the users, get this kind of a device, this will help you, or get it fitted in such a way, this will help you. Even that awareness is missing. And of course, the acceptance, right? Even if you have the right device, you know about it, you can afford it, you can access it. When will you accept it? When you feel that it's really helping you, right? Similar to the eyeglasses. I know that I cannot function without them. I cannot do my best job without the glasses. If I'm always squinting, trying to figure out, what, it's not an effective way of doing it. So it makes me independent. I don't have to ask somebody to read out something for me just because it's, or keep it at a particular distance, right? Because as you get older, you can read certain things, there's a sweet spot where you can read things perfectly, but, everywhere else it's a blur. So and the devices also, see, eyeglasses are not ugly looking, they don't give this medical device feeling. It's not, they look cool. So why not other devices? Bicycles look cool, two-wheelers look cool, right? We all want to be associated with things that look cool. Even phones, when they were earlier bulky and all that, they didn't take off the way they have taken off now, right? So acceptance is very important, because only if the user accepts the device, they are likely to use it. So these are some challenges in this space that we have to address, even when we are doing, any kind of product development or any system development in this area. AT kind of has to always keep these factors in mind. Movement disability, of course, can occur because of various causes. There could be medical causes, natural causes like aging. We all, as our life expectancy with, advances in medicines and all that, our life expectancies have gone up. We can all expect to live a lot longer than, say, a few generations earlier, where reaching the 50s or 60 was something very special. Like in our culture, they celebrate the 60th birthday. Nowadays, it's normal. I mean, if anybody dies before 60, it's considered abnormal. But in those days, it was something big, because reaching the age of 60 meant you had a really good constitution. A lot of things went right for you, right? So aging, and what you are at 50 and 50 is not what you're going to be at 70. What I am at 50 plus is not what I was when I was your age, 20s and 30s, right? You do feel that decline that comes. I never wore glasses till I was 40. My vision was perfect. I never thought I would need them. But it is going to happen. It's inevitable, and it's better that we embrace it and look at technologies that can still help us live full lives, rather than saying, oh, this is happening to me, and because you can't stop it. I mean, the only way out is like, what's the alternative, right? It's not so it's so we need to start getting, and I think with the younger generation, with more people getting interested in assistive technologies, we need to normalize the use of assistive technologies. That's essentially it, because that will go a long way towards removing the stigma that we now associate with using assistive technologies. My mother, she's close to 80, but she will refuse to, she refused to use a cane to walk till recently. And then when she started using it and she realized how much more independent she became, she was like, oh, okay, now. But it's getting over that barrier, that this is going to help you. So our goal is, if you look at the spectrum of assistive technologies that are available, especially in a developing country like India, you see that what we mostly see around us, what's mostly easily available, are very simple, low cost, but somewhat primitive technologies even. And simplicity is good. Simplicity is generally good, but if a device is too simple to be even functional, to help the person using it, then it's not good. Then it becomes primitive, right? And that is usually, you see these one size fits all wheelchairs, those hospital wheelchairs, where the person is sitting there and they can't even reach the wheels to kind of self-propel. It's not something that enables independence, right? Then even with prosthesis or orthosis, which are like artificial limbs are called prosthesis. Orthosis are like these supportive devices that people use when they have some kind of joint dysfunction or muscle weakness. You may have seen people who have had polio usually end up losing their muscle strength and have to use some kind of a supportive device. So what we generally have available here are very primitive devices. They're very low cost, true, but they don't really, most people just reject them. The acceptance factor is gone, because one, they look very clunky, they scream disability, they scream dependence, they scream disability, and therefore nobody wants to use them. I would rather stay home than be seen outside wearing something like this. And what happens is, people with disability get excluded from social interactions. They may develop mental health illness. So it's like a very vicious cycle, because they are not able to interact because of the lack of the appropriate devices. Some people may be fortunate and they may be able to afford some imported devices, right? They may be some sophisticated devices. There's a lot of technology that's available outside, and they may be able to afford it. But that one, the cost is exorbitant. So very few people will be able to afford that. Even if they are able to afford it, if something goes wrong with the device, it's a high-tech device, you will not get any replacement parts, you will have nobody will know how to repair it, you'll probably have to ship the device back to the country where it came from. Think of all the expense, the hassle. You'll probably have to live months without that device. A device that you have grown to depend on, right? Again, that is a bad situation to be in. Many times, it also happens that many of these devices, you will see a video of them, there'll be like a press release, there'll be a lot of buzz about it, but you wait for years and years and nothing happens. It's stayed in that lab where it was first developed. There's a lot of excitement, but you don't see it. And even if you see it, like exoskeletons, they're extremely expensive. They look very hard to use even, and it just doesn't seem very practical. How are you going to make an impact with some very sophisticated technology like that? And in this field, if you don't get your devices to the end user, you are not going to make an impact. Somebody watching a video is not, it's not the same, it's not going to help me if I want to be independent. I see one person doing great things with a fantastic wheelchair. If I can't get hold of it, it's useless to me. So what we have been trying to do at R2D2 is trying to design, so somewhere in the space, in the middle space, right, you still want devices to be fairly simple yet affordable. It should be more functional than the really simple devices. So you want better functionality, you want good quality so that these last longer or they can be easily repaired. It should be to international standards again, and it should be aesthetically pleasing. It should not look like a machine strapped onto you. And of course, affordability has to always be there, because many times after a disability, you may not have as many opportunities to work. So you lose your means of livelihood, or you have reduced means. You may not have as easy an access to education. Your options may kind of become limited in terms of what you can do. Like, STEM education for people with visual impairment. That's a huge challenge. Equations, figures, all that, right? Kathy talked about some of that earlier. So most people with visual impairments tend to go into humanities, because that's where they can leverage their strengths. But it's a limitation of the environment that is imposing that disability. They may be very analytical. They could have probably made great scientists or engineers, but we are limiting them because we are not able to give them the resources to excel. So this is what we try to do here. It requires an interdisciplinary approach, because you have to interact with the different branches of engineering, you have to interact with clinical professionals to understand the nature of the disability and to understand the abilities when someone is disabled, what is it that they can do. We talked about people with visual impairment being able to process audio at 10 times the speed as someone who has vision. So how do you use that ability, use their abilities to kind of overcome what they can't do? right? So, so it requires a very interdisciplinary approach. Of course, we work in a very, R2D2 we work in a very narrow area, which is movement disability. But it's a complex situation, and that's why it requires an interdisciplinary approach. So these here are 4 of the devices that we have commercialized so far. You have the prosthetic knee, the Kadam prosthetic knee. Then you have the Neo Bolt and the Neo Fly. So you see a wheelchair and you see like a vehicle there, right? That's an add-on to the wheelchair that converts it into a roadworthy vehicle. And then we have the standing wheelchair, which I will talk about in a little bit more detail today. So I think all of you now understand the context of disability and the challenges that it poses. So I will now, since we're going to talk about the standing wheelchair, I thought I would have you, write a few things so that we can then share why a standing wheelchair. So before we address that, I would just like you to think about, as human beings we stand, right? What are the benefits? What are the benefits of standing? And then think about what could be problems. So our world is designed because most of us stand. What could be problems if you cannot stand? So yes, most of you came up with these things. So contractures are like your muscles get shortened, if they have not been stretched at all, and that can lead to joints staying in a bent position, right? So they are tightened, and therefore, like, stretching them may be painful. Contractures can happen if you're always in a wheelchair. You can have pressure sores because in many cases, like say after a spinal cord injury, you also lose sensation. So you won't know that, so there's no pain, right? Jennifer is here, she can help us understand that better, but you won't be able to feel the pain, so you don't know that you're putting too much pressure in one area. And if that skin breakdown happens and you don't notice it and you don't treat it, it can actually be life-threatening. So it is a very dangerous secondary complication of being in the seated position. So standing as therapy is something that is very important for people in a wheelchair, regardless of other benefits of standing, because there is a study, an exhaustive compilation of the literature. There was a white paper by the Rehabilitation Engineering and Assistive Technology Society of North America. It's called RESNA, and they brought out a white paper that shows the benefits of standing. Okay, for wheelchair users, they said that standing is something that has to be performed because it improves the circulation. So you can see the health benefits there. Improves circulation, bone health, because in the human body, anything that you don't use kind of goes away if you don't exercise, right? That's why they say, that's why it's important to exercise. Bone density goes down if the bones are not being loaded. If you're in the seated position, the bones in your thighs and hip and the lower leg are not being loaded because the seat is taking all the weight. So your bones start weakening. Range of motion, like the contractures, they reduce your range of motion. So if you stand, all these improve. Bone health improves, your range of motion improves, and even your vital organ functioning. Your respiratory system improves, your excretory system improves, because human beings are designed to be bipeds, right? So the physiological systems are counting on us spending some time in the upright position. Therefore, these doing standing regularly is, we all know that Even now we say, right, a sedentary lifestyle with all these devices and gadgets. We've all grown into a sedentary lifestyle, and we need to, people keep timers or use their smart watches to, it'll say get up and walk, right? I still use an analog watch, but yeah. So it's important, it has various health benefits. And for people in wheelchairs, it reduces the risk of pressure sores, urinary tract infections, that's another complication that it helps to reduce. Spasticity is, sudden spasms in their muscles, sudden activation and contractures. So there are many more. So if you have a chance to read the Resna paper, I'll probably put the PDF, it's available freely. It has gone through decades of research on the benefits of standing and compiled, and their recommendation was standing is important. Standing as therapy is important for wheelchair users. Besides that, majority of people, we are, you're in a room, everybody is standing, right? There's one person in a wheelchair and they feel, everybody is talking down to me, right? So for self-esteem, that confidence that you were talking about, if you're in a room full of people who are standing and you're the only person in a wheelchair, then it's hard to have an eye-to-eye contact while you are talking to somebody. If you're in a room full of wheelchair users, that's fine, right? So because you're operating as equals, it feels like, it may not be the case, but it feels like somebody is, just as with children, right? As parents, you can, as long as they are tiny, you kind of feel like you have the upper hand because you can just talk down to them. When they get taller than you, then the role reversal happens. So it's good for self-esteem, and then functionality also. Most of our spaces are designed for, so there you see Jennifer doing a push-up, because that's something, if she's not, they have to do on a regular basis to avoid the pressure sores and, to kind of the joint mobility and all that. So you can see that on a regular basis, some of them do push-ups like that. But functionality is something that, most of our switchboards, anything that you want to operate, they're all at levels where you have to stand to operate them. Or you have bookcases, they're not always at this level, You have refrigerators, bookcases, they're all designed to go up vertically. Space utilization, we do a lot of vertical space utilization. And those spaces now become inaccessible if you are on a wheelchair. Here is a video that shows how a person in a wheelchair, how a person who has a movement impairment, in this case a spinal cord injury, how that person typically does standing for therapy. Okay, so I'll just play this video.
In 2012, I met with a road accident. Post that, we noticed my spine got a severe injury. So after surgery, I am using wheelchair. Suddenly, a fraction of a second, I lost my walking ability. So it's very hard time for me and my family as well.
Life in a wheelchair can be eventful. Day-to-day aspects of mobility demand effort and assistance, often leaving paraplegics and their caregivers overwhelmed. Hours of sitting in a wheelchair can cause secondary health problems to the user, like poor blood circulation and reduced bone density, among other issues.
Mind of injury people definitely need a physiotherapy 2 days in a week. So it will avoid our bed sore and all. So our leg get spasm otherwise.
So this is how he does standing. He needs the help of two other people. He has to wear those orthoses. You can see, we do it without thinking, right? We get up without thinking. But for a person with a spinal cord injury to stand, this is the effort that it takes. So this is the problem we thought we would address. Okay, so this was there are standing wheelchairs out there, so it is not something, but there are none available in India that are not imported. Okay, so we don't have any solution, we didn't have any indigenous solution here, so it was definitely not accessible to most of the population that uses wheelchairs in India. So here is one place where the need was not developed. We had no idea about the need, or nobody came to us with the need, because we were just starting out in this journey. But it's a need that we researched and found from literature. So we knew the context here was different, right? That much we knew. But it was not a need that came out of interactions with wheelchair users. So, sometimes there could be problems like that where you get it from the literature, other people have solved it, there are still problems with it because there are not many commercial standing wheelchairs. There are very few, and very few which are manual. See, we wanted our design to be manual for the reason that cost. You add motors, you add batteries, again the cost, the maintenance requirements, all that is goes up. So we wanted to see if we could come up with a manual solution that would do this job of standing while you are in the wheelchair. So integrating the standing function into the wheelchair. That idea by itself was not, it's been around. But can we do it? First of all, it's an engineering challenge. Okay, that was what first attracted us to it. So it started off as a class project. Say I teach courses on mechanism design. So I had my students for their final project just look at coming up with a mechanism that would perform, that would move a wheelchair into a standing position. Okay, so because I saw some GIF of that, I don't know if I have that here, but I saw that and I thought, this could be a linkage synthesis problem, and that's how it started. So this was in 2011. 2011 was when I gave my students this problem, and then a student, Harshal, who's there in that figure in 2012, he decided to take it up as his final year project. He was intrigued by in this class they just made, like cardboard models, or they just a 2D. They were just looking at, okay, can I move from the seated position to the standing position? What does it take? What kind of a linkage would I need to do that? And there were very different solutions. Okay. Then Harshal decided to take it up as his final year dual degree project, and his thing was to do a more in-depth analysis of the problem from an engineering perspective, because when you stand up, we don't think about it, but we are essentially lifting our body weight to the standing position, and it's not an easy task. So when somebody can't stand on their own and you try to lift them up, you'll know the challenge, right? So if you're trying to help an elderly person, they can't get up, and you're trying to help them up, you know what kind of effort it takes to do that. So our problem initially was like, let's solve this engineering problem. Let's see if we can do this with manual effort. Because you're going to have to use the strength of your arms to lift yourself up, because your muscles below your waist are not working. They're not going to help you in this task. If you don't have any problems, that's what helps you. Those muscles are the ones that help lift you up. So he tackled that problem. He did simulations, he analyzed it, wrote the equations, and did all that, and finally built a wooden model. And then in the first time he built the model, he could go up a little bit, but after that he couldn't, no matter how much effort he applied. he couldn't do it. And we had the equations to show why we couldn't do it. So we knew that we had to do something else. So we looked at spring balancing. It's, for instance, in your car, right, if you have a hatchback or the trunk, that's a huge chunk of metal right there. But you can open it easily with your hands. I don't know if you've noticed, but inside you'll see 2 gas springs. Okay? Those springs help balance the weight so that the effort that you apply is very low. So we looked at how do we apply that to this problem. So you have to be looking at, your inspiration may come from anywhere, not just from another assistive technology. So we did some research on, how to do spring balancing, how to incorporate spring balancing in this. And by the end of his the year, he just used a regular coiled spring, but he was able to actually apply enough effort to go to the standing position. So you can so he built one with metal so that it's a little bit stronger, but you can still see it's very crude. The prototype is very crude, but he was able to demonstrate that he could apply the effort to come to a standing position. And it was such a rickety prototype, only he would dare to operate it. None of us wanted to even try it because it was like, okay, you have the confidence, it's your baby, you do it. We don't, yeah. So then he left, he went on to do other things. I asked some other students to work on the next prototype. Make it a little bit more robust, maybe so put in gas springs, because the problem with the the coiled springs is you'll just spring up. It's not, there's no damping that's available in it. Okay, so it can feel a little abrupt when you, and we knew that that's not a good, that's not a good feeling that you're sort of being pushed up suddenly, So the next set of students, there were some interns, I had them work on it. So it took 2 years to get somebody to work on this and make another prototype. And then you see 2014, we were able to come up with a prototype that people without disability, probably some of us could try it, and it felt okay. It felt, we had one person with disability who was brave enough to, luckily we also had a therapist. That's very important that you have a medical professional with you. So he came and tried this prototype. What happened was, as he was able to apply the right effort, and he was not exerting himself overly to come up with. But as he started moving up, his feet started sliding off the footrest. We just had 2 plates for the footrest. And this was something that none of the other people had experienced. We were all able to. But it was something we were doing unconsciously. We were gripping the footrest with our feet, and when a person who didn't have those foot muscles, who didn't have control over those foot muscles, operated it, you could see that the feet were just sliding off the footrest as they were coming up to the standing position. Which is why it is important that you not only test it on people without disability, because it's easier to test it on people without disability. You don't have to worry too much about ethics or them coming to potential harm. It's not so hard. But only when you test it with the actual intended users, you will come across some of these other problems. Okay. So we realized that, okay, we've validated the mechanism for doing the standing, but we have a long way to go. This was in 2014, and that's when we got a grant. So we had this prototype, and then we really wanted to bring it to the market. And so there was a call for proposals from Welcome, and we applied for it, and and luckily we got the grant to work on it. So then we could have dedicated people. See, the problem with students working on it, they finish it, they're on to the next thing. Unless they really want to stay in this field, for them it's a project, I've submitted my report, I've got my grade, tata bye bye, right? In most cases, that's how it is. Some students may stay longer, but unless they decide to stay back after their degree and continue to work on it, it's very difficult to make this journey. So that's why from 2011 to 2014, that's how far we came. And then, but when we got the funding, we were able to hire people to work on it full time and say, look, this is our task, this is what we have to do, this is. So in 2015, we built our first. So you can see here, I just want to show you that it took, for it to come to the market, it was 2019, end of 2000, so nearly 10 years from the time, it was an idea and some basic literature review and research, to the time that it became a product. If we want a person with disability, people with disability to be able to try it, right, we need to have certain safety features built into it. We need to have certain things that, so we had to redesign the footrest, for instance. We realized from talking to some therapists also, that the knee support is very important for a person to be able to stand. Because one of the reasons they're not able to stand is because they don't have the muscle control at the knee to transfer the body weight. Chest support. Many people with spinal cord injury might not have trunk control. So you need something, you need some form of chest support. So we just looked at existing thing, and this was also the first prototype. So as part of and I'll talk about the grid model a little bit later, but you see here that this was a collaborative effort. Grid is a collaboration model. So we were doing the research, Welcome was providing the grant, the money to do the research. We as an academic institution were doing the research. We also had an industry partner, because to kind of make prototypes that are robust enough, you need good facilities, you need good fabrication facilities to do that. And eventually also to go to commercialization, if you have an industry partner on board from an early stage, it's a good thing, because you can then design for manufacturability, you can address some of those things along the way. And we have also had dissemination partners. Dissemination partners are like user groups, NGOs, other users in the community who will come and test your device and give you feedback on what is working, what is not working, what could be done better, the co-design, with, and not just users but also healthcare professionals, therapists, because they know, how this therapy is typically done, and what is important, what sort of safety features are important in the design, right? Because the user may not be able to tell you that. If they have not experienced a standing device, they're not going to be able to tell you what sort of things, what sort of safeguards I need to do that. And we also knew that we had to make this prototype adjustable. We knew from our calculations, from our analysis, that somebody weighs 50 kgs, somebody weighs 90 kgs. The effort to move from sitting to standing is not going to be the same. So, and also, so the ergonomics, right, how they are able to apply that force, all that is going to vary depending on their height and weight. So we knew that, so we had done all the background analysis for that, but we knew that we had to incorporate that kind of adjustability into the prototype. Because if we want to, we can't have a prototype, this is a complex device. It's not easy to make 10 different prototypes at once, especially in the initial stages. So we had to make sure that we built in adjustability, made it modular, so that we could adjust it to different users and make sure that each person got the same, had the same level of ease in operating it and had. So we worked with the industry partner to design. You can see it still looks like a machine, right? It looks like, it doesn't look like something I want lying around in my living room, right? So, but it's a process, it's a journey. So we put in these, and Vadi, who is here in this picture, he is a very inspirational person. He was studying at IIM Bangalore when he had his spinal cord injury. He fell from a balcony and sustained a spinal cord injury. But he showed tremendous perseverance. After his treatment, he went back, finished his MBA at IIM Bangalore. Then he went on to work in many corporates. But through all that, he was also, he had his rehabilitation in CMC Vellore. So every week he would go there to inspire other people who are recovering from spinal cord injury. And he would tell them, no, you can do this. He was like a really, his impact on the community was huge. He started a foundation, a couple of foundations that catered to people with spinal cord injury. He collaborated with different, like IIT Madras. He came and he collaborated with us on some projects. He would be very happy to test even like early prototypes. He would be very willing to test and give feedback, and he would be ruthless with his feedback also. See, because sometimes, people, and that's important, because if somebody tells you, oh, it's good, unless you probe and ask a lot of questions. With Vedi, we never had that problem. He would tell you exactly what is not okay. And if he says something is good, then you also know that it's okay, you're on the right track. So, unfortunately, during COVID, he passed away. But he was a huge support for the work that we were doing. And I think what we are doing today, a lot of it is a tribute to Vedi and the kind of inspiration he was for us. So this is a video of that early prototype. You can see this was in CMC. It wheels like a regular wheelchair, and you can see this is this boy. His biggest complaint was his mother would put his phone on the top shelf if she didn't want him to reach, if he was using it too much. So he also plays basketball, and he wanted to be able to do that. So he tested this. You can see that he's not straining to move from sitting to standing, and that is because of the adjustments that are built in. So for each user, those adjustments have to be made. And you can see here some of the analysis that we did. This is like a small portion of, we had to figure out, like, how do we adjust it? Which way do we move if the user is heavier or lighter, because we wanted to make it very modular and adjustable, because only then you will get cost savings in manufacturing. We realized this when we wanted to benchmark this with an imported wheelchair. We knew there was a company in the US that makes an imported wheelchair, a good manual imported wheelchair, and we said, let's get that and see how this one compares to it. And when we contacted the company, they said, okay, tell us where the user is, we'll fly out there, we'll take measurements, and then in a few months you'll have your device. So they custom make it, right? And that's not going to be a model that will work for people here. If you want it to get to more people, that's not a very and the cost of it would have been, to get it and then import it, would have been over 10 lakhs for the manual wheelchair. Luckily, we were able to find a user in Chennai who had the same device, and so we were able to go there, take a look at it, and then have the user also try ours later when we were ready, market ready, so to speak. But there's a lot of adjustments that need to be made for each user. One size will not fit all, because even in the standing position, right, you have to have the right posture. You don't want to cause more harm than good. You don't want to give a one size fits all standing wheelchair and have somebody get hurt because it's not the right fit for them, or it requires them to apply enormous effort. They're not going to accept it, right? So some key learnings from the early trials were, every user who tried it was really happy to be able to stand. That, the standing feature they were really happy with. It's like, wow, I can do so much if I'm able to stand. And they felt that it would improve their quality of life. One lady, she said, now I can cook. I don't have to ask people to get me this and that, and I can access the shelves myself, and I can do the cooking at home. And when the adjustments were made, according to their weight and height, people were able to use the standing facility easily. There was ease of standing, and people, quadriplegics who have higher levels of spinal cord injury, they were able to use it, but they were not able to use a handle where you had to hold on like this. They didn't have that kind of a grip to operate it. But when we provided them, handles that they could push, like, we call them the quad handles, when we attached those to that, then they were also able to operate it up to like the C5 level. And then one of the things that did not work very well, one, the looks of it, obviously it looked like a machine, and it was difficult to propel. See, because of all this metal, this mechanism and everything, the weight of that wheelchair is considerably higher than your regular wheelchair. You're trying to move a larger mass around, right? And many times it's not even terrain. So it was difficult to propel. So we kind of solved the standing part, but we kind of took away from the wheelchair part. The propelling part, which is why you're using a wheelchair in the first place, to move yourself from place to place. So we had to now figure out a solution to that problem. So even though, okay, we have the standing part is okay, but we wanted to look at wheelchairs that are considered to give good propulsion, because not all wheelchairs are equal. That's a mistake even many clinicians make. They just say, go out and buy a wheelchair. There are wheelchairs and there are wheelchairs. There are good wheelchairs, there are bad wheelchairs, there are ugly wheelchairs. You have all kinds of them. And so since we couldn't get the other one for benchmarking, we thought, okay, at least let's look at propulsion. What are wheelchairs that are considered good for propulsion? So benchmarking is something you do with existing devices. You look at what are the features that you want to kind of compare them on. We do this all the time on Amazon, with phones and other things. So I don't have to tell you what benchmarking is. So indoor propulsion, outdoor propulsion, because in Western countries, they are more or less the same. Indoor and outdoor propulsion are not very different because you have smooth surfaces. In India, it's not the case. indoor and outdoor propulsion can be very, very different. Turning radius, right? So we looked at some different types of wheelchairs that are considered good for propulsion, and we found one by motivation which has like 3 wheels. We found that that was something that people found very easy to propel. Okay, and they are used in some states more than others. I think they're just available more. But people who use those wheelchairs said they are able to go outside even on uneven terrain quite easily. So we thought, okay, let's. So this is just an aside on the user trial process, because we're talking about these user trials. It's very, and Kathy also talked about it when she talked about ethics, right? You have to have very clear-cut objectives for your user trial, and the inclusion-exclusion criteria are very important. Who do you include in the trial? Okay, how do you select people to be part of the trial? What kind of exclusion criteria? Some of them may not be suitable. They may be able to use the device later with maybe extra therapy or something like that. But at this early stage, you don't want to include them because, again, you may be causing more harm than good. So somebody with a contracture who already has a contracture was probably not a candidate at this stage for trying out the device. So then outlining the trial methodology, so objective of the trial, we wanted to improve or validate some of the features, the aesthetics, the comfort, the effort required, the safety, the harnessing, how easy is it to put it on or how easy is it to take it off, get all kinds of user inputs, the usability of the device. We said we want to try it only with adults, so 18 plus, height, most people are between 4 feet and 6 feet, 40 to 100 kgs, that's what we designed the prototype for. And somebody who's used to using a wheelchair and perhaps a standing device. You don't want somebody who has not stood at all for years to suddenly use a standing device, because they may not have the bone density to take the sudden load. They could still, with therapy, with some strength training, probably get up to the point where they could use a standing device, but not at this stage. And, that's a call that needs to be made by medical professionals. Some of these calls you want to have medical professionals as part of your team, especially when conducting the user trials. It's good to have them even during the design stage. And so some of the exclusions were persons with contractures or some other kind of skeletal deformity or osteoporosis again, and some kind of, even your BP, when you stand, you could go into, so you could, your BP could suddenly fall, right, and they could faint. So you don't want them to go into that kind of a situation. So standing intolerance, any kind of standing intolerance, we didn't want to include people in. And so these are sort of the steps. You demonstrate the device functioning, you show them how it works, you explain the risk and benefits. Don't tell them only the good part. I think that's something that was reiterated. Explain, how long are they going to be here for? What are you expecting them to do? So we just wanted them to do some activities. Come up to the standing position, again sit down, then maybe try to reach for something in the standing position. So we had a list of tasks we wanted them to perform, and then you have the therapist examine the person. This probably should be done before they are enrolled in the trial. Obtain written consent, that's very important. And then you explain, you teach them how to use the device. Okay, they may not get it in the first try, but you train them to use the device. You perform the trial, collect the data, collect the feedback from the user. This is sort of like a one slide thing on how to go about the user trial process. And to minimize the risk, especially with a population that has disability, you have to be extremely careful. So apart from, first you do testing by persons without disability, so that any initial things you can work out problems there, because I may be able to regain my balance quickly if I or have it done with people around you. Don't consent and demo, these are all things. You have medical experts and domain experts. So I could have medical experts, but if they've not handled people with spinal cord injury, then that may not be enough. So I may need to have an occupational therapist or a physiotherapist who's used to handling people with spinal cord injury as part. Train on that, provide them the training, show them the demo, show them how to use it. And of course, if you use proper fabrication techniques, don't take a 3D printed wheelchair and ask someone to sit on it. It may not have the strength. You should know what kind of prototype is fabricated for what purpose. Sometimes you may fabricate things using 3D printing, but that may just be for you to get, inputs on the looks of it or the feel of it or, other things. But structurally, it may not be sound enough for someone to try it. So you have to know what kind of fabrication methods are. You may need to have insurance when you do trials, so that if somebody gets hurt, they can be compensated for the medical treatment. So it's a very complex process, developing an assistive device. Again, use computer tools like finite element analysis. You do mechanical testing in the lab setting to standards that are there. I'll show you those. You do all this to minimize the risk. So all this should be done before you actually try it on a person with the disability. Especially a device that is sort of not something that they are used to. If it was just a wheelchair, you have a wheelchair with some more features, fine. But this is something you're making them do some tasks that they have not done before, that they're not currently doing, that they've probably not done since their injury or whatever resulted in them using the wheelchair. So this is another, immersion is another important factor. So you're doing user trials, but for the user trials, they probably come to where you are, or you go to certain sites where they do it. But immersion is actually, as designers, going into their environment, into the user's environment, trying to understand their lifestyle, trying to understand their living conditions, and that's very important, because when we went for the standing wheelchair trials, you need not even take the device with you. You go there and you look at what are they using now? Are they using it? How are they, what is their house like? It tells you a lot about their lifestyle, about the kind of support system they have or don't have. Because for many people, like in rural areas, they were not doing any standing therapy because they don't have, other people have to go to work. They don't have two people to come and help them stand up and put them in a device and then half an hour later, help them get back down. They don't have access to any kind of therapy like that. You look at the, surroundings, and it's full of potholes, it's like really uneven terrain. So they're not even using that, regular wheelchair, the medical wheelchair kind of thing that they have. They say, what is the point? They just crawl around the house or something. Because that wheelchair is of no use to them. It may be, so many of them are very broad, right, the wheelchairs. So they won't even go into their houses. So they don't have a lot of space to maneuver. Somebody has to push them around. If somebody is not there to push them around, I'm not using the wheelchair. Outside, the terrain is so bad, I'll fall off the wheelchair. So it's basically of no use. The wheelchair, the wheelchairs that are typically donated, those are people don't use them. They just sell it for scrap or something, for the metal later on. So it helped us understand the lifestyles and the challenges they face in their environments, in their day-to-day life, you know. So these immersion visits were very helpful. The field visits were very helpful for that. So this is mechanical testing. You can see we built these devices. This is to ISO standards. We have what's called the double drum test. So it has to pass 200,000 cycles on that test. And I don't know if you can see it, but on the drum there are slats provided to simulate bumps. Okay, so I think 200,000 cycles corresponds to like 3 years of life of the wheelchair. So you look at the components. After it's passed the test, you look at how it's survived. You know, is there any structural failure, etc. Then we also have a drop test. So it's called a curb drop test. So you have curbs, right? And you have to, so it's lifted about 5 centimeters and dropped down. And they do it 6,666 times. I'm not sure how they came up with that number, but yeah, if it survives the drop test, the double drum test and the drop test, then yeah, it's good to go. Of course, in the field, you can always encounter something that you didn't plan for, but you know, these are some quality standards that are necessary to meet. So this slide kind of captures the whole design journey. In each version, you know, we had the issues that we identified. You can see that here. What was the functionality we wanted to achieve? We had that, and you can see the dark green is when we achieved that. The light green is when it was a work in progress. Okay, we wanted to achieve standing, customizability, outdoor mobility, and we had to work with industrial designers for the aesthetics, the look and feel, usability, like when they are moving to the standing position, you don't want the clothes to get caught between the linkages. So how do you, you know, design for that? How do you reduce the complexity? So the first design you saw, it was like a machine. Look at the last one there, the commercial version. It looks a lot simpler. How do you still, so we had to like rethink our mechanism design. Okay, and using the 3-wheel kind of helped us reduce some of the complexity. So it helped with the propulsion, and then when we started using the 3-wheel design, we thought, hey, we don't need this other linkage that does something else, you know, that provide, that's there for stability in the standing position. So we were able to kind of mix and match and, you know, iterate and come up with something that we were finally happy with. I'm sure we can do better, but at some point you have to say this is it. As designers, we can go on and on and on trying to, but at some point you freeze the design and you say, okay, I know this is not perfect, but it's something that I can live with and something that we can then take to. So you can see that there was a lot of user-centric design involved because users were involved in every design iteration, users and clinicians. So the stakeholders, the important stakeholders were part of the co-design, and we were able to innovate on an existing device. So yes, standing wheelchairs are out there, but we were able to do some things different. For instance, the safety features that are there in this design are very, somewhat, it was because of our conditions that we thought of it, but they're applicable anywhere. It prevents accidental standing. So if somebody is passing by and just hits that lever, it won't, you don't want to be, you know, caught unawares when you're trying to stand up, right? What if somebody just made you stand without you wanting to do it, without you intentionally wanting to do it? That's disconcerting. So we didn't want accidental standing to happen. Then we made the knee block removable for portability. We wanted to make this portable so it could be carried in an auto or a car or something. It's not something that people would do on a regular basis because it's still heavy. We were only able to reduce the weight to about 30 plus kgs. Started off at 45. But still, it's quite heavy, but the 3-wheel makes the propulsion easier. But we wanted to make it portable, so if they were going out of town or they're moving, they should be. So the wheels were made removable, it could fold down, and the knee block had to be removed for that to happen. But the knee block is a very essential part of the standing. And therefore, we wanted to make sure that if the knee block is not in place, the person should not be able to stand. So there's actually a mechanical lock that gets deactivated only if the knee block is properly in place. And it will allow you to stand. The standing mechanism is activated only if the knee block is firmly in place. So this was just before launch. We did a user experience study with about 30 users of people who were admitted in the at St. John's Hospital. So each of them used it in their daily lives for about a week. But it was in a controlled environment. It was in the hospital, but they could go outdoors, they could do things within the hospital. So they had, it was different from the earlier trials where so this was more long term. So you can see this user, he's showing you that he can exercise in it when standing and not feel insecure. He's quite stable. So before the launch of this, we did a proper study in a hospital setting, and you can see of the final version, you can see he's able to do a wheelie and get over that speed breaker. And then these are some of the other people who were in the hospital at that time, other users who tried it. And most of them were, I think they were quite happy with it. So when they gave the thumbs up, we said, okay, we are ready now. We can go forward. So this is the one that we tried to get for benchmarking on the left side, the super stand. You can see that still looks like more like a machine than the one that we finally came up with. And this costs about, this is, I think the cost to the user would be about 30,000 rupees. That's about 10 lakhs if you had to import it. Maybe in the US it costs a little bit less, of course, with imports and all that. But it's a significant, it's an order of magnitude difference. So this is what it looked like at the launch. And one of the most emotional moments was when the MC said, please get ready for the national anthem. And the users on stage actually stood in their standing wheelchairs, and it was a very emotional moment. Many of them were standing for the national anthem for the first time since their injury. So you can see here at the my left corner, the person standing there, the guy standing there, he's the one who was doing, who was in that video with that, with the physiotherapist and his wife helping him stand. So he's now standing independently on the stage for the national anthem. And since then, we've also added one more industry partner to, manufacture this device. And several hundred have been sold, but we are hoping that we can get many more out there. And the grid collaboration model is, so essentially, it requires this ecosystem. You need some analysis, you need some understanding of biomechanics, you need some mechanical testing, tools like finite element analysis and that's what we've tried to build at R2D2 for, and we want to make the journey from prototype to product to market, you know. And we've realized that just the device is not enough, the awareness and education. So we have an awareness video to see, so people can determine. I would get a lot of calls, I want the standing wheelchair. So I would say, please go watch the awareness video, please see whether the device is suitable for you, right? It may not be suitable for everybody. Like very old people, they'll have, their bone density may not be good enough to perform, to use this kind of a device. So I would tell them, please, so we've created these resources. We have forms that, you know, we've trained 1,500 therapists across the country to kind of assess for, you know, generate the prescription and then help fit and train with this wheelchair. So it's a holistic process that you have to look at. It's not just about designing a device, because without the training, they would not be able to effectively use it. Without proper fitting, they would not have a good user experience, which means they will reject it. So how do you make them use it? So this is the grid collaboration model. I already told you about that, but it can help create affordable devices, because the grant is from someone who really wants to make an impact. They're not looking for monetary returns from the exercise. And the research also, because it's done in a research institution, there's a lot of resources that are pulled in that are not really accounted for in money terms. Like the grant does not have to pay my salary, for instance, or does not have to pay for a student's, you know, if there's a student involved, because all that labor is free. The infrastructure that we get, we can do I'm not paying rent to IIT for my lab, you know. Whereas an industry, a private industry, if they had to do this, it would cost them several times. And then where would they recoup the money from? From the customers. So they have to price the device considerably higher. So this is, you know, the collaboration model that we've been able to work reasonably well with to commercialize these devices. I think I will stop here, but you know, working in assistive devices also aligns with the UN Sustainable Development Goals, because you want to increase access to livelihood, community participation, education. It fosters innovation, entrepreneurship, and you're trying to reduce the inequalities in society. You're trying to integrate people of different abilities into society. And you can only do this with partnerships like, you know, GDI Hub and R2D2 IIT Madras. We are working on some exciting projects together. And you know, when you have a shared vision, it's easy to work with your partners. So you need to find like-minded partners. That's very important when you're working in this area. So our motto is innovate in India, but go global. So I hope this, I know I've taken a little bit more time than I intended. I just get very excited when I talk about this, and thank you, Kathy, for giving me the extra time.